Okay, coolio. Let me. Okay. How many of you know that we have an SI for this class? Right, so we have an SI for this class. Her name's Joanna. I think she should have sent you guys out an email. So like, again, you should be checking your email. I'm expecting you to be checking your emails all the time. So that's the reason why she has 3 hours a week for you guys that she can help you with. She's supposed to be here right now. She might show up later. But she is a senior. She's really great. So if you can't make it to my office hours, Joanne emailed you about times to meet with her. Again, find an email. And yeah, she might talk next time. Not sure. Okay, cool. So I graded homework 1. If you turned it in on time. If you didn't, then I'll just grade it on Friday when I grade homework 2. You can, for part B, which is the part that you were to turn into Blackboard. If you click on it, your submission, I believe, it'll send you to like your submission. And then I wrote comments about the grade breakdown for that part. And then for part A, which is on WebAssign, a few of you still have not got WebAssign, please get WebAssign. That I just pulled from WebAssign. And if you need, right, because you get like a 10% deduction every week that it's late, WebAssign, you need to request that I give you an extension. So if you need more time on WebAssign, request an extension. All right. Homework is meant for practice. So I try to grade evenly though, like pretty loosely, not as hard as I would grade an exam. On part B. For part A, you guys get, I think, like 100 attempts on every problem. So you should be getting nearly 100 on your homework that's on WebAssign. Time dependent, obviously. What else? Oh yeah, make sure you're doing the right problems. So you had homework problems for homework 1 in section B.2. So that's chapter B, section 2 in there. Some of you did the question that was in chapter B, section 1. We didn't go over that section. So section 1, you need to just be careful that you're doing the problem in the right section. Remember these chapters, the letter chapters are in the back of the book. And if you don't know the page numbers, I would look in the table of contents. All right. Homework 2 was posted on, I think, Saturday. Sorry, I had so many meetings on Friday. And it's going to be, again, due at Thursday at 11:59 p.m. So part A is up and part B is up. So today we're going to finish C.1 and maybe move on to C.2. Does anyone have any questions? Okay, cool. So oh yeah, that was our fun little exit slip last time. Whee! Remember, conjugate just changes the sign in front of the term with the square root. So if it's a negative, it's a positive, positive. Okay, that's totally fine, Griffin. So we've been working with expressions prior to chapter C, so things that didn't really equal a specific number or some other value. That's why they're called expressions. Think of it like a sentence without a period, something like that. And you can simplify an expression, but you can't solve an expression. you can only solve equations, right? Equations are statements that two arithmetic equations are equal, right? So we had like 4x plus 7 equals 19. 2x plus 2 equals negative x. X squared plus 2, I'm not going to simplify that to negative x. That's not possible, right? We think of x as like the unknown, also call it like the variable, and the values are called the solution. To solve the equation, we isolate the variables on one side, and to do this, we use the following operations. So we add or subtract the same quantity to each side, right? It's kind of like a balancing act. They're equal. I can't just add something to one side and not the other, then they're no longer equal. Think of it like a seesaw. And then equivalently, we can multiply or divide each side by the same non-zero quantity. And the reason that we say non-zero is multiplying both sides by 0 just gives you 0 equals 0. And then we also cannot ever divide by 0, so that's another reason why. So when we are solving for x, we just kind of want to make our little function look like x equals something with no other x's on that side, right? So we could have done lots of things in this first problem. We were given 5 times 3 plus x equals 9x. We chose to multiply the 5 through the parentheses. But I could have also divided 5, right? I could have taken and then divided each side by x, by 5. So these 5s would have canceled out. I would have given 3 plus x equals 9x over 5. That's another option that I could have done. Can you see that? Okay. My chat was hiding that on my screen. And then worked from here and done something a little similar. Collected x terms by subtracting x onto both sides. So I get 3 equal 9x over 5 minus x. Oh, that's a 5. What would I do from here? Yeah, we can always talk after class. I'll be here for like 5 to 10 minutes after class. We could multiply by 5. That's an option. When I multiply by 5, I need to make sure that I'm multiplying 5 by every term, right? So that 5 is gonna, here, let me not write it like that. That's kind of confusing. Multiplying by 5 on each side. Right, so 5 times 3 is 15. And then I get this 5 and this 5 cancel out. So I get 9x minus 5x, which simplifies to 15, 4x. And we get the same place. 2 ways to get the same place. You could have also, from here, made just like x, like 5x over 5, and kind of done something like that. It's kind of whatever you're comfortable with. Solving equations, there's no one way. There is an easier way most of the time. All right. Okay, we're going to move on. Whee. So first, we're going to talk about linear equations, right? Each different type of equation comes with another fun way to like solve it. All right, so a linear equation, I abbreviate equation EQN. Is one variable in an equation that is equivalent to one of the forms. So it usually will look like ax plus b equals 0, where a and b are real numbers and x is our variable. So unlike a little example would be like 2x plus 3 equals 0. Something like that, right? right? The key technique to seeing that if it's linear is to put all the variables to one side, right? Does anyone know why we call this a linear equation? Well, technically, plotting this on a graph, ax plus b equal to 0 would just give me x equals something, which is just a point. Anything in this form where your highest variable is to the first power is a line. If I had it equal to like another variable called y, anything higher than if x is like to any other power, it's not linear. Fun fact. All right, cool. So our key technique is to put all variables onto one side. So for our first example, 7x minus 4 equal to 3x plus 8. Are all of our variables onto one side? No, they're not. So I usually like my left side to be my variable side and my right side to be I call constants, just numbers, no variable attached to them. Those are constants. So like variable side, equal sign, constant side. And that is just a preference. You're in a question 4 equals x equals 4, literally the same thing. It's just because usually you write your answers like x equals. So it's usually easier to put the variable on the side you want to begin. Sometimes it might be better to go another way if you don't like dealing with negatives. All right. So my variable side, I'm just going to subtract 3x from both sides. And let me, oopsies, I'm going to erase and I just highlighted. So 7x minus 4 equals 3x plus 8. And I'm going to subtract 3x onto from both sides. So minus 3x will give me 7x. Right, I'll get 7x minus 3x minus 4. 3x, oops, not 3x. Equals 8, which is equivalent to 4x minus 4 equal 8. So I put all my variables onto one side, but I still have a constant on my variable side. So I'm going to do kind of what I did in the first step and move it over to the other side, right? I'm basically just sorting everything. So I move 4 over by adding 4 to both sides, and I get 4x equals 12. Great. Now I have variable side and constant side. But have I isolated my variable? No, right? It still has a 4 kind of like buddied up with it. It came to the party with 4, and now it's like, oh, 4, you're kind of annoying me, go away. So since 4 is multiplied by the variable, to undo that, we're going to divide by 4. And that yields x equals 3. Great. How can I check my answer? I'm going to plug it in. So over here, I'm going to say check. 7 times 3, right? X equals 3. I usually like to put in little parentheses. Minus 4, 3 times 3 plus 8. So we're going to check that x equals 3. Oopsies, not equivalent. It is 3. Okay. 7 times 3 is, I really suck at my 7s and my 8s. Oh, this is embarrassing. 7 times 2 is 40, 21. I had to stay after school in elementary school to learn my 7 and 8s tables because I was really bad at them, but I was in gifted math. I just couldn't ever get 7 and 8s. Oh, and then 7 times 8, terrible. Okay, 21 minus 4 is going to be what? 1, 20 minus 3, 17. And then 9 plus 8 also is 17. Yay! And then you get to check mark because it's right. Alrighty. How you guys feeling about that? Thumbs up, some sideways, and thumbs down. Okay. Coolio. Okay. Thank you guys. All right. Now let's bump it up a little bit. Now I ask you guys to solve x divided by 6 plus 2/3 plus 3/4 times x. Is this don't check your work unless you're asked to check your work. You're in college now, so I'm not going to ask you to check your work, but if you have time, I would check your work. If you're going to get graded on something where you can check your work, I would check my work. Is this still a linear equation? Yeah, right. I still have x. This is still just an x. It's not an x squared. It's not a 1 over x. It's still an x. And same with this guy. Still just an x. Just because there's fractions involved doesn't automatically make it not a linear equation. Remember, 1/6, 2/3, and 3/4, they're all still real numbers. But I hate fractions. There's lots of ways to do this problem, but I personally hate fractions. How can we get rid of them? Right, I can multiply by the least common denominator. And honestly, what might help is like, oh, like 6 is the biggest number. Let's multiply by 6. And so I get 6 x over 6 plus 2/3 plus 3/4. Let's just do 12. My point is, if you don't multiply by the least common denominator, you can multiply by something again, eventually moving up to the least common denominator or more. But I just really want to get rid of these fractions. So 3, 4, and 6 give me a least common denominator of 12. All right, cool. So then I get 12x over 6, which simplifies to, let me write this out, plus what, 24 over 3 plus 3 times 4 is 36. All right. So this is 2x plus 24 divided by 3. Oh my God, is it 8? Yay. And then 36 divided by 4. 40 is 4 times 10, so it's 4 less than it, so 9. 9x. Thank you. All right, cool. Do you guys agree that 2x plus 8 equal to 9x is a lot easier to handle than this fractions? It's the same equation. I just multiplied it by 12 on each side. Same thing. Right? So let's do what we've been doing. So let's subtract 9 onto both sides. What we'll get, negative 7x. Whoopsies. Plus 8 equal to 0. You get negative 7x. Oh, here. So then I want to get 8 onto its own side. So I get negative 7x equal to negative 8, which then gives me x equals a positive 8/7 because those negatives cancel out when I divide by negative 7. Right? Think of the two negatives coming together to make a plus. Could have also added, subtracted 2 onto both sides up here. And it would have been a lot quicker. So that's why sometimes making a variable side and constant side might not be as fast, but if you're okay with like switching each side of the equation, it's not a big deal. All right. Do you guys want me to check this one, or you guys feel like we're pretty good on this? Because I can plug in. I also want to start hearing from like other people that haven't been participating. Maybe I'll call on names. Thank you, Elizabeth. Okay, cool. Right, because like I just want to make sure that everyone is doing good and I'm not, I don't know, going too fast or something. Okay, cool. I know I didn't check it right there, but I could have if I wanted to. But you should always check your solutions, even if you don't make make mistakes. You might discover what is called a extraneous solution. And we're going to talk about, we're going to solve this crazy problem, which looks not linear, but it just have little bits of linear things in it. Those are all linear. Same with this guy. And we'll see why it's very useful to plug in your solution. Okay. So I have 2 plus 5 over x minus 4 equal to x plus 1 over x minus 4. Remember last time how I multiplied by 12 to get rid of my fractions? What can I multiply by here to get rid of my fractions? Yeah, x minus 4. I don't have to just multiply by a number. I can multiply by a expression like x minus 4. So we're going to do that on both sides. X minus 4. Oh, there we go. X minus 4. And then on this side, x minus 4. All right. So then I'll get 2x minus 4, 5x minus 4 over x minus 4. Those will cancel. So I'll get plus 5 equals, these guys would cancel, and I would be left with x plus 1. That is a 4. All righty. Then I'm going to distribute this 2 to help me. So I get 2x minus 8 plus 5 equals x plus 1. Going to combine, distribute. That's not how you spell that word. Distribute. There we go. 2. Combine like terms. So combine variables and constants and constants. So 2x minus 8 plus 5 is going to give me -3. And now I'm going to move things around to get to my variables. So I'm going to subtract x onto both sides. That gives me x minus 3 equals -1. Oopsies. Oh, that's a plus 1. Plus 1. And then I'm going to add 3 onto both sides. Plus 3. So I get x equals 4. Alrighty. But we need to check our answer. Right, I check all the way up here. So I'm going to have 2 plus 5. Instead of an x, I'm going to put a 4. 4 minus 4 equals 4 plus 1, 4 minus 4. Well, that gives me 2 plus 5 divided by 0 equals 5 divided by 0. Does that work? No, it doesn't. So I'm going to take the box off of this because it's not our solution. So since I'm dividing by 0 and I only got a 4, we would conclude that there is no solution. Because of that we checked it. Does that make sense? All right, awesome. And the reason that this problem showed up in linear problems, even though this is like fractions with x's on the bottom, is because once we multiply x by 4, we get a linear problem. So if anyone's wondering where that problem came from, out of like left field. Okay. I'm gonna scroll down. Oops, I was supposed to plug in my thing there. Okay. Now we're gonna talk about power equations, right? So last time we had x just to the first power always. But now a power equation, we're gonna call it x to some any power n, right? So if x equals x to the n equals a, it either has a solution where x equals the nth root if n is odd, or it's plus or minus the nth root if n is even and a is greater than or equal to 0. Does that make sense? So like this would be like if x cubed equaled a, the solution would be x equals the cubed root of a. And this would be like x, let's do the fourth, that's more fun. Would yield that x equals plus or minus the fourth root of a. Alrighty. Oh, I have 2 Chloes. Crazy. Okay. But if n is even and a is less than 0, what do you think we can conclude? We're going to conclude that the equation has no real solution. And I want to kind of harp on this real part, right? Taking a square root of, or even root of any negative number yields what's called an imaginary number. If you've ever seen like this cute little eye, whee, that's the square root of -1. It's imaginary. Imaginary. We don't deal with imaginary numbers. So once you take the square root of a negative number, first check yourself and make sure you're doing the right thing. But if that's our final answer at the end, then the equation has no real solution. It has a solution. Don't say it doesn't have a solution. Imaginary numbers, just the square root of -1. And oh, well, imaginary numbers are like 3i, which would be the square root of -9, which is just the square root of -1 times 9. So 3 times the square root of -1. That's all what I is. And then when you add real numbers and imaginary numbers, those are called complex numbers. This is way over your head. You don't need to know this. Basically, if you're ever divided by, if you're not divided by, if you're taking an even root of a negative number, you're going to tell me that there's no real solution. Okay, it's different from what we just did, where I got a solution and then it caused me to divide by 0. That solution caused my equation to be undefined, right? Being divided by 0 is being undefined. But dividing by a negative puts me into imaginary world. Therefore, I have no real solution. So there's a difference between no real solution and no solution. Does this make sense? Taking even roots of a negative number in this class is illegal. Okay? Great, moving on. So, few examples. If I want to solve x to the 5th equal 32. Yeah, let's see if I can, I can keep that up there. So n is odd, right? And in this case is 5. I'm not going to explain odd numbers to you all. what's happening and how we get this nth root is if I have x to the 5th equal to 32, I want x to the first power, right? That's how I get x equals, that's x to the first power. So to undo this 5th, yes, we'll get there. Okay. I'm going to raise it each side to the 1/5, right? That's the 5th root, right? So then that gives me x to the 5/5. And I can rewrite 32 to the 1/5 as the 5th root of 32. Bing. And these are just ones that you have to know. 5th root of 32 is just 2. I think any of these I'm asked, I would never ask you anything over like 4. 32 is like the only 5th root I ever expect anyone to know. All right, cool. So similarly, x to the 4th, I would write to raise everything to the 1/4. So I get x equal, is it the 4th root of 16? What am I missing? Abby, what am I missing? Plus or minus, right? It was because it was an even root and 16 is positive. So I can just keep going from there, right? Does anyone know what the 4th root of 16 is? It's 2. These are all 2, by the way. So, or sometimes -2 will make an appearance. Plus or minus 2, okay? Now I'm mixing it up a little bit. We just did it where x to the 5th equaled 32 and x to the 4th equals 16, and now I'm throwing in some negatives. X to the 5th equals -32. I'm going to do what I did before. 1/5, 32, 1/5. I'm basically I'm raising x to the 5th by the reciprocal of the power. Remember, the reciprocal is just, I flip it if it was a fraction to get x to the first power. Can I take the 5th root of a negative number? Yeah, I can. Because this is actually going to be -2, because -2, -2, -2, -2, -2. This gives me 4, 4, and then just a -2. So there's that negative. Multiplying something by itself an odd amount of time, so that thing is negative, one of these negative pieces is going to be alone, and it's not going to have another negative to cancel it out. That's why odd powers, you keep the negative, and even powers gets rid of the negative, and it kind of undoes that with roots. So what is that? 16 times 2, -32. Right? Remember this, if I have an odd power, I'm going to have an odd number of solutions. You can only have usually one solution, right? And if I have an even power, I have an even number of solutions. Okay, 2 solutions, plus or minus. Okay. Yeah, that was our answer. Here, let me square these. Okay, what about x to the 4th equal -16? Right, it's going to give us an imaginary number. So you don't even need to worry about imaginary and giving me an answer with I. I don't want that. I really just want this, and then you'd be like, thus no real solution. Don't tell me there's no solution. It's kind of wrong. There's just no real solution. Alrighty. How are you feeling about those power equations so far? Thumbs up, thumbs sideways, and thumbs down. Okay, I understand that. Meh. It's kind of frustrating when you get a positive solution, you get a positive and negative solution, then you get a negative solution, then you get no solution. Yeah, that's fine. I like to, Abby asked if we can put it under the radical instead of multiplying by a fractional exponent. Such a fancy question. Yeah, that's fine. Like writing it like this. I was just kind of giving the reason why we go from this to this, because the textbook doesn't really explain that well. And I think once we move on to bigger, scarier equations, it's good to know to raise it to the reciprocal of the power. Okay. And then eventually you guys are going to be able to solve things when it's like 4 to the x equals like 16. Oh, it's going to be so cool. Okay. Here we go. Oh yeah, like this one. Oops, my eraser. I like to like, that's kind of one of the reasons. Instead of just like x to the something, I have something else. Okay, cool. Oh my gosh. I emailed my boyfriend and he just emailed me back. It's really funny. So solve the following equations. We have x squared minus 5. What I was looking at before was x sum to the sum power equals something else. I don't have that right now. So taking the square root wouldn't be really smart. If I did like, and I just took the square root here, well, I can't, exponents do not travel over plus and minus, addition and subtraction. We know that because that's why we have to FOIL things. So I can't do anything here. That would be kind of like, I don't know, it wouldn't do anything. So instead, we're going to prep our equation. So I'm going to move the 5 over. Minus 5 equals 0. So that I can take the square root of both sides. Just like that. Now I can take the square root, right? Can I escape? Wait. Can I take the square root? Is anything dangerous going to happen? No, because I have a 5 and it's a positive 5. Even though it's not.
What do you mean by dangerous?
Like negatives. Am I have any negatives that could like scare my answer?
Gotcha.
Yeah.
Thank you.
We could take square root of any number, right? So let's do what Abby asked me if I just draw a little radical. And yeah. I just get square root of 5. Yeah, it is hard to simplify, but it's kind of also nice because that's all you need to do. Oops, what did I forget? I forgot something. Yeah, I forgot my plus or minus. Okay, coolio. Okay. So in the first problem, I needed to move some things around before I took the square root. But in number 2, I have subtraction inside of my square root, inside of my square, right? So basically I have x minus 4, the quantity squared, equal to 5. So what do you guys think I should do first? Can I add 4 to both sides? No. And also something I don't want you to do is don't FOIL this. Don't try to you see something squared like this, we just talked about factoring, and you FOIL it out, and then you have x squared and x. That's complicated. We haven't even talked about how to solve those types of equations. Don't mess with it. You have something really good right here. Don't ruin it. So I'm going to take the square root of both sides. So x minus 4 squared equals 5. Boop, boop. So I'm going to take the square root of both sides, and I'm going to remember my plus and minus. So this is going to yield me x minus 4 equals plus or minus 5. You can keep that plus or minus right there. Some people also write like x minus 4 equals 5 and x plus, no, not plus, x minus 4 equals negative 5. And then you have two equations because you have two solutions to the square rooting. Oops, where did my square root go? Sorry, I'm just so excited. Boop. There we go. Make that negative a little bit bigger. Alrighty. But I can just keep it as a plus or minus right now. It's fine. Right? The only thing that's getting me in the way of writing my equation as x equals is this nasty negative 4. So I'm going to push them to the other side by adding 4 to both sides. So I get x equals, I can either write plus or minus 5. No, not 5. The square root of 5 plus 4. Oh my God. My little brain is doing too much. Plus 4. Or I can just write 4 plus or minus the square root of 5. All of those are equal, right? And that's also just like saying x equals square root of 5 plus 4, and x equals negative square root of 5 plus 4. All of these are equivalent. Okay. How do you guys feel about that problem? Yeah. Negative square root of 5 cannot be simplified anymore. If I give you like square root of 9, I kind of expect you to give me 3. But I don't expect you to know, I don't like decimals. Okay, cool. Mostly good with a few sideways. I'm going to skip 3. I think it's kind of along the lines of what we did last time. What time is it? It's 5:08. Okay, we have 30 minutes. I definitely want to do 5. How many people think they want to see 3 and 4? You can also like just say 3 and 4.
Can you do number 4, please?
Okay, we'll do 4. And then we'll also still do 5. Great. So, we could take the 4th root of this guy first, just because the numbers work out nice. But I kind of just, again, like to get x alone. So kind of get rid of this x 16 and then get rid of its exponents. It's kind of like undoing PIMDAS, if you remember order of operations. I like add and subtract. I want to get rid of things that are added and subtracted from x, the AS. And then I want to get rid of things that are multiplied and divided by x, the MD. And then I want to get rid of exponents, the E. And then once that, I can undo all the parentheses stuff, which we did in the second problem up here. So there's nothing added and subtracted. Great. So now I'm going to get rid of numbers that are multiplied by x. 16. So I'm going to take 16x to the 4th equal to 81, and I'm going to divide both sides by 16. Great. Those cancel out, and I get x to the 4th, 81 over 16. Can I reduce that fraction at all? No, I can't. 81 is divisible by 3s and 9s, and 16 is divisible by 2s and 4s. Great. So I can't. So no more reducing. I just have to take the 4th root. So I don't think I have enough room to do this here. Let me do to the 1/4, 1/4. So I'll get x equals, it's an even root. Just because it's not a square root doesn't mean it's not an even root. Oh, I'm about to sneeze. No, I'm not. I lost it. Whee. 81 over 16. And I need my 4 right there. When you're writing these radicals, when there's a fraction, I need you to be really careful that it kind of looks like the whole fraction is there. This is not equivalent to saying 81 over 16. That's just 81 to the 4th root, not 16. Those are two different things. So I need you to be really careful about how you're writing this because I don't know what you mean if you write it like this, okay? So just be careful. All right. So we know from our exponent rules that I can distribute this 4th root to 81 and 16, right? It's just to the 1/4. So I can put it to 81 and to 16. I can leave the plus or minus outside. So 4th root of 81 over the 4th root of 16. Is everyone okay with the reason why I only have one plus or minus and I don't have like plus or minus over plus or minus? Okay. Does anyone know what the 4th root of 81 is? It's 3. 81 is 9 squared, and then 9 is 3 squared. And then 16 is 2 to the 4th. So the 4th root of 16 is just 2. So I get plus or minus 3/2. And again, we can always plug in and check and make sure that we're right. You'd have to plug in both solutions though. Don't forget that. I need to plug in positive 3/2 and negative 3/2 if I wanted to check this. Okay, great. Any questions about this problem? Okay, great. So I love this problem. I don't like decimals. I dislike decimals more than I dislike fractions. So let's make these decimals fractions. Does anyone know how to do that? Which one is 1/5? There's 2 decimals. One of them is going to be 1/5. Exponent. Yeah, right. 0.2. If I have like 0.1, this guy is in the 10ths place. So I would write any number that's right there, like 0.2 is going to be 2 over 10. That's what that means. The next place is the 100th, so it'd be like 1 over 100, and that's how you would get that. So that yields 1/5 and 0.6, which is 6 over 10, equals 3/5. Okay, so that would give me 3 equal to, oh, not 6/10. 3 over 5 times x to the 1 over 5. Great. So I want to get rid of this 5 that I'm dividing by right here. I don't really like fractions, remember? I can't get rid of this fraction exponent quite yet. So let's get rid of this 5 that's down in the denominator. Remember, we have to undo PEMDAS when we're solving. You can take everything to the 5 right now. I really don't recommend doing that. So I'm going to multiply each thing by 5. So then I get 15 equals 3x to the 1/5. And then I want to get rid of my 3. So divide by 3. And I get 5x to the 1/5. All right. I could have also done like done both of this in 2 steps by multiplying by 5 and dividing by 3 at the same time. You're multiplying by the reciprocal of this fraction, but it doesn't hurt. Alrighty, oopsies, that should not be a 2. 15 divided by 3 is 5. That 5, this 5. CJ, which 5 are you talking about? This 5?
Yes.
Okay. That 5 came because I wanted to get rid of this 5 in the denominator because I didn't like fractions.
Got it. I see it.
Yeah.
Thank
You could have also multiplied by 5/3, which is equivalent to when we multiplied by 5 and then got rid of that 3. Ow, my leg. Okay. So I've only had to take if it was like n was like a positive, was not a positive, it was a whole number. Now I have a fraction. So it's gonna kind of work the same. Right? So I have x to the 1/5. So I would want to raise it everything to the 1/1/5. That is equivalent to just raising everything to the 5th power. Oopsies. Is that clear? Right. And then I wouldn't expect you to know this off the top of your head, but you would plug this into a calculator because this would be on your homework. And you would get x equals 3,125. Yes, it says 1/1/5, right? Because you want to raise it to get rid of this 1/5. I want to raise it to 1/1/5. I want to raise it to the reciprocal because then it would cancel out and I get 1/5 over 1/5, which is just 1. But that's the same as 5. 1 is not the same as 5. All right. I love this problem. And if I love a problem, it means you're going to see it a lot. Yeah, that's why you kind of like writing fractions within fractions is kind of confusing. So you like would usually write like a bigger line to indicate the main fraction. Alrighty. Do I have another problem? Okay, cool. So we talked about a fraction. X with a fraction and the exponent. So let's talk about x with a negative. Alrighty. So I want to get rid of that 3 first, right? I'm undoing PEMDAS to solve equations. So I'm going to divide by 3. So we get 3x to the -5, 2, divide by 3. So I get x to the -5th equals 2/3. What am I going to raise each side by to get rid of that -5 in the exponent? Not the square root of 5. Remember, I want to get x to the first power. So basically I'm saying, what do I multiply -5 by to get to 1, well, I would multiply it by its reciprocal, which is negative 1/5. So basically take this number and put 1 over it, and that's what you're going to do. One over -5 is also the same as negative 1/5, which is what Ronald told us in the chat. All right. So that gives me x equals 2/3 to the negative 1/5. Can I simplify this at all? Yes, Ronald, what can I do? What do you mean by least common denominator? I only have one fraction. Well, okay, I have two fractions, but one's in the exponent. So an answer should never really have, unless specified, that you should have them, negative exponents. I hate negative exponents. Well, I kind of like them because I don't like fractions, but I don't like negative exponents. So what would happen? How can I get rid of this negative exponent? What do you mean by put it under 1? Oh, I know what you're saying. Right. Right. So I would have like 1 over the quantity 2/3. But I can think about it as flipping it, right? It would just negative exponents indicate the reciprocal. Remember, reciprocals I just flip. If it's a whole number, yeah, it's 1 over that whole number because any whole number is technically over 1. But this is 2/3. I can just write it as 3/2. That's a 2, not a z. As a 2. Is everyone okay with that? If you're a little uneasy about negative exponents, I would suggest going back to somewhere in chapter A, where we talked about negative exponents. What do you mean same thing? Yeah, 1 over the quantity 3/2 is the same as, oh, not 3/2. I mean, yeah. 1 over 2/3 is the same as 3/2, but it's kind of improper to have a fraction in the denominator because you can simplify it to 1 fraction. Yep. Okay, cool. How are we feeling about power equations now? Good, meh, or blah? Ooh, Charlie threw in a pretty good. Okay. Alrighty. All of those were goods or miss, which I will take. Alrighty. So now we're going to talk about solving for one variable in terms of another, right? So in other fields, equations will involve more than one variable, right? Time and amount. Newton's law of gravity. I have gravity, mass, acceleration, a rate of some sort. I have lots of things going on. We'll often want to get one variable in terms of the other. Say I have 2 equations. There's just lots of reasons why I would need one variable in terms of the other. The way that we're going to do this is we're going to treat the other variables as numbers. If you also want to kind of think of them as constants, they're not variables at all. I'm just going to think of them like as numbers. A number would be a constant thing. So, well, who do I know to solve for? You'll be told who to solve for, right? So in this example, solve t times x. So if they're next to each other, they're just multiplied, just like if they were numbers. Tx plus t plus 3x in terms of x. So t here, even though it is a letter, and letters usually do indicate variables, I don't care about t. T is pi, or not pi, that's bad because that's also a symbol. It's like 10 or something. I don't care what it is. It doesn't matter. I'm not solving for it. I'm just going to treat it if it was literally 10 or something, another number. Don't write 10, but just it's a number. Okay. So tx equals 2t plus 3x. What should I do first? Or what can I do first? Right? I want to subtract 3x. I want to gain everything that or put everything that has x in it to one side. Alrighty. So minus 3x, minus 3x. And this is where that little bit of factoring that we did in chapter B kind of comes in handy. I also write my t's with little wispy tails. Why? I don't know. Just how we write them in math. What's going to be left on this side? 2t. Great. I brought up that factoring part is, remember, I want to get x by itself. So I moved all of these things over here so that I can get x by itself. So I want to isolate my variable. What can I do? I can factor out x, absolutely. So I pull x out of each term. Remember, terms are added and subtracted from each other. That's going to leave me with a t and a 3. So t, a negative 3, minus 3 equal to 2t. Beautiful. Now I have x multiplied by something. So to undo that multiplication, I'm going to divide by each side. So I get that x equals 2t, right? Those two cancel out, over t minus 3. Oh my God. Okay. How do you guys feel about that? Pretty good. Yeah. The important part is this stuff right here, factoring out that x. But that's why we did so many things working on factoring and stuff. It all builds on itself. Oh my gosh, are we going to end? Yes. We're going to end today at the end of a section, and I love doing that because it just makes everything a lot better. All right, cool. So Newton's law of gravity is F equals G little m times big M. That's on purpose. Little m and big M are two different things. All divided by R squared. Solve for big M. Okay. So let's rewrite our equation. Oops. So now we don't have any numbers, we just have letters, but the process is still the same. I'm still gonna act like all these other things are numbers. All right, if it says solve for M, that implies that I want at the end an M equals something, right? So what should I do first? Or what can I do first? I always say that. What can I do first? Right, multiply by R squared. right? Because I want to move it to the other side and it's being divided. To undo that division, I'm going to multiply. So I get f r squared equal to g times little m times big M. I will have, now I want to just have m equals, so I'm going to divide each side by big G and little m. And I can do it together, it's fine. I don't have to do one at a time. Ta-da!
I have a question.
Yeah, I love questions.
Yeah, like if that lowercase m was like a capital letter, like let's say it was a capital R, like could you still do it together, like GR together, or it has to be like a capital and a lowercase?
Oh, yeah, no, that doesn't matter at all.
Okay, gotcha.
So what if I had like f equal to G big R and little r?
Yes.
Yeah.
Like, cool.
It would work the same. Those usually think like when they give something a little m and a big M, it usually means there's just two variables that start with M. In mathematics, we're very boring, like G, gravity, F, force. Probably they had like mass and like momentum. And they just didn't want to come up with a different variable, so they named one big M and little m. Would have worked the same. All right. Does anyone have any questions about that? I think that was easier to ask a question, so thank you. Whoever won. Okay. Doo-doo-doo. Oh, someone just screamed outside my yard. Okay. Janet, Joanne, are you here?
I am, yep.
Yay! Do you want to give a little spiel about being an SI and how fun it is?
Absolutely. So my name's Johanna, guys, and I'm the SI instructor. Sorry, I'm a little sick right now. I'm the SI instructor for this section of Math 111. A little bit about me. I'm a senior at USC, and I'm a math major. So I really enjoy math. My sessions that I hope 3 sessions a week, and I do them Tuesdays and Thursdays from 6 to 6:50, and that's through the Blackboard link on the course webpage. And I also do one on Sunday that's from 4 p.m. to 4:50. And if you guys aren't able to make those days and you still want to go to SI, you can always go to the main like SI page. I think I sent it out in an email in the beginning. Where there are other sections and times you can always go to for Math 111 if you need extra help or anything. And yeah, you guys can always pop in if you have any questions or ever want to go over review or homework or anything like that. And I'd love to see you guys.
Yay! Thank you. Okay. So if we don't have any more questions, and if you guys have any questions for Joanna, you guys can ask them now. But if not, we are going to do our exit slip and then call it a day. All right. So remember, our room number is my last name and then 943. And then your teacher question of the day is hold on, there we go. That wasn't going away. So after you tell me about how you felt today and what we learned, I want you to tell me, when is one time that Johanna holds SI. Woohoo, you guys are paying attention. I want you to give me day and time. Make sure you guys are really paying attention. If you already quickly answered, that is fine. Once you finish your exit step, you guys are free to go. If you guys had homework questions, then I will be glad to talk about that. I don't need to record. Stop recording.